Big Data and Data Science Meetup Group, and we have Thulani on the call. He's going to present on RPA. But before going into that presentation, I would just like to give you an update on any DAMA updates. So the one update is that there's a conference that's free for all DAMA South African members on the 2nd or 3rd of December. That's going to be held remotely. It's organized by DAMA Ireland, the same people that we helped set up the teddy bears. So that's if you go to the DAMA EMEA, or if you contact me, I'll share a link for you. And I think it's a 3-day session, which is completely free for DAMA chapter members. So I don't know if there's anyone interested in attending that. There's all sorts of things from data strategy to data ethics to all sorts of interesting presentations. So if you are interested, I've just got some feedback. Okay, great. So that's the big update from DAMA. The next events and next month's event is going to be on the 19th of July. At 1600 same time, same link, and that will be using data science tools and techniques with big data to do micro weather forecasting. And interestingly enough, this is a friend of Drew's. I believe this is the person we spoke about, and he does a lot of this weather forecasting for hang gliding and micro. I'm not sure the exact which one it is particularly, but it's someone who uses it quite actively. And then on the DAMA chapter meeting, we'll be just putting that one together. We will be looking at doing a one from hopefully One Trust in Papaya that will be presenting with I think it's one of the lawyers in South Africa. That's what we hope to have set up. Ins and outs of data modeling, that will be happening again on the 5th of July. We're going to be doing another level of detail or a deep dive into fact-oriented modeling. And you may have seen some of the discussions on LinkedIn with the differences between ORM and FCO and all those. There's some really interesting discussions there, and it's going to be focusing on extracting the requirements from our business users. So how do we model the facts about the business? Then we've got CDMP Q&A every Friday. So anyone who wants to understand how to do the CDMP exam, I know Gwenele can actually give you a talk as well. We hope to have a few of them on one of the presentations where they talk about the process that they went through. Gwenele, hoping you will join and share with us some of your experiences. And then we have the career pathing on every Thursday. And now this month we're doing metadata. We are doing it for data management professionals, and we're hoping to get, I don't know if you guys remember, we had Guillermo, I think, I can't remember the name, I think it was from Italy, and he has a whole lot of classifiers of metadata to do data lineage, data asset catalogs, and stuff like that. So we're hoping to get him on and almost to have a big data / metadata presentation. All right, so that's what's in store for us in the next month or so. And then I'd like to hand over to Mishimo to introduce Thulani. Mishimo.
Oh, sorry. Thanks, Howard. Good afternoon, everybody. Today we have Thulani, and I met Thulani while he was presenting at one of the conferences that were hosted by MTN. And I was impressed by the work that he's doing around intelligent automation. And I just thought maybe it would be great for us to have Thulani in this session to showcase how people are merging big data, data science, and also the concepts of automation. Welcome, Thulani. And I think we'll hand over to Thulani. Yeah.
Just a question, Thulani, before you start. I was looking for you on LinkedIn. So if anyone looks on LinkedIn, there's someone with your exact same name who's doing RPA at MMI. Any connection?
No, that is not me.
It was amazing because it's exactly the same name, and I saw RPA and I clicked on it. I was like, oh, this is MMI. This is not you there.
Yeah, no, that's not me.
Okay, all yours, sir.
Okay, thank you so much for the invite. I must say, I appreciate it. I understand that we have until 5. I was planning to keep you until just up to 7:30, if that's okay.
We can keep going. We can keep going.
All right, great. Let me just quickly share my screen.
Fantastic. Thanks, Thulani. Thanks so much for being here and helping and presenting.
All right, so let me know when you can see it.
Yes.
Yeah, we can see it.
All right, now that's fantastic. So I thought I should just kick off the presentation on a lighter note, right? Obviously, big data analytics, as we know it, well, the term as we know it is born of the 4th industrial revolution, along with the robotic process automation, cloud computing, mobile, Internet of Things, and so on and so forth, right? So everybody's talking about the 4th industrial revolution that has given birth to all these things. But I just thought it was interesting to just touch on this because I didn't know of the 3rd industrial revolution, the 2nd, and the 1st. And if I speak to a lot of people, they say big data, yeah, part of the 4th industrial revolution. But nobody really understands what the 3rd and the 2nd and the 1st revolutions were, right? So not that this is important for our conversation today. I just thought it's an interesting fact or a point to note so that you know. So that on Friday, when you're having a braai with your friends, you can tell them that you know the 1st and the 2nd and the 3rd industrial revolution. You know what I mean?
Yeah, we can brag.
Yeah. So as you know that human beings long ago, we all used our hands to do everything. It was a lot of intense manual labor. But some smart people, as we have smart people today, decided that why don't we innovate and mechanize some of these things that we're doing. And that was also the introduction of steam power, you know. And then in 1784, that was considered the first industrial revolution where industries were established. Now, instead of people working in silos doing things for themselves, industries were formed where people could come together and utilize these available mechanisms, the mechanization, steam power, and so on and so forth. As time went on, obviously around 1870, smarter people thought that, look, we are producing things one by one, you know, and that is very labor intensive. Why don't we introduce mechanisms where we can produce these multiple things at the same time? And my understanding is that Henry Ford was very instrumental in the introduction of the assembly line. And that was then termed the 2nd industrial revolution. I would presume that some of us in this call may have been born when the 3rd industrial revolution was introduced in 1969, where automation came in, computers and electronics and so on and so forth. So today, we are speaking of cyber physical systems where, experiments are going on. If you know that Elon Musk is busy working on his chip that will be implanted in our heads. And I just learned the other day that actually here in South Africa, at the University of Witwatersrand, they have conducted an experiment where they were able to upload data to a human brain.
Oh, wow.
Right. So those things are already happening and they're very close to home. So now we are speaking of the 4th industrial revolution. Interestingly, with the 4th industrial revolution, a lot of people are already looking at the 5th industrial revolution. So big data was born of this, where now a lot of things could be connected at the same time. And obviously data has to be harnessed because now all these things create a lot of data, all the communication, the conversations that are going on back and forth between these objects. There's a lot of data that's going on. So we needed to think that how do we harness this data to help us make smarter decisions, improve businesses, and improve people's livelihoods. So for the purpose of this conversation, I decided to streamline, to focus on one specific industry just to make sure that this conversation is focused. But as you will see that the things that I am speaking about, as you know, that big data is applicable in many other sectors. The things that I'll be talking about, though focused on telecoms, are relevant in many other industries as well, as we do big data in every other space. So I just thought that to help focus the conversation, let me bring it down and just focus on the telecoms industry, and we can take what we discussed here today and apply it in every other area. I also just want to request that if you may have points that you want to add or questions, can we park those to the end so that we can flow with this presentation, and then at the end we can quickly have a discussion, because I do value a lot of inputs and insights from colleagues in the digital industry. So we're looking at big data and the telecoms industry, obviously applying robotic process automation and machine learning in that space. But as I said, this is applicable in many other industries as well, right? So if you look at businesses as a whole, these things, although this is telco focused, but these things are applicable in many other industries. I mean, in many other businesses. We do have customer experience. So whether you're doing a business that is a B2B or a B2C, in a B2B, the other business would be your customer, or you would be their customer, vice versa, however the setup is, right? But you do have that leg in a business where you are concerned about your customer experience. And these are some of the areas in customer experience where we can then utilize big data, targeted marketing, predictive churn analysis, customer life cycle. So network optimization, for instance, if you look at a business like, let's take Takealot.com. Takealot.com is not necessarily a telecommunications company, but because they are hosting a tech-intensive business, which is web-based, connectivity is very important. Therefore, their network optimization is critical. So this is just to say that though the focus here is on telco, you can see that these things are applicable in many other spaces as well. So these are just some of the areas where big data analytics are applied to help businesses make better decisions, right? Operational analysis and data monetization. But what I need to bring forth with this, because obviously this is information we know. I mean, we work with big data every day, and we know the areas where big data is applied. So this is just an example that if we look at the cases that I've just presented, these are just some of the examples of the data sources where if big data is to be harnessed for businesses to make better decisions, they would at least have to look at these data sources to make those decisions. And network infrastructure, there's 8 or more data sources that you can look at in marketing and sales, also 8 or more. So if you think about data analysts or data scientists, right, you want to ensure that their work is not focused on the management of the data sources and the collection of data. You want to ensure that their work is just on the analysis of the data, dealing with the models and so on and so forth, to make sure that they are getting results from the data. But what you find in many instances is that because we have so much data that is available, structured and unstructured data, you often find that these skills are often wasted in the collection and the sorting out and the fixing and so on of the data. And this causes a lot of headache, because now we spend little time in what we are actually supposed to be focusing on, and spend a lot of time on the collection of data. So this is a headache. So now, if you look at the tools that are available in the industry, there's a lot that you could do. If you can write code, then you can automate some of these things. You can probably write a Java program that can collect all the data for you from all these different spaces. But the issue with writing code is that you now need to employ a skill or a person that would be able to write the code, manage the code, fix the code when there are bugs and when there are errors. So a better way of doing that would then be the introduction of robotic process automation, right? So I am going to present this as if in this group, nobody knows what the robotic process automation is, but obviously that's a lie because this is a group of very highly intelligent people. But if you look at the robotic process automation, it is basically applying software bots, not really physical bots, but right, software bots that are able to do some of the things that humans do. Like the collection of the data, for instance, you could bring in a software bot that can do that. So instead of having people focusing on the collection of data, the bots can do all these things, right? I just want to, before I go deep into it, I just want to play this video. Let me know if you can hear the sound.
RPA is the software technology that performs transactional.
Sorry, can you hear the sound?
Yes, we can.
Okay, awesome.
Activities in IT applications in the way a user would. All RPA applications have the following structure: a digital input of structured data, and a process logic based on rules, conditions, loops, etc. to act on the data received. A software robot has the great advantage of being much faster than a human when carrying out tasks. Let's see. And they don't get sick, don't take vacations, can work 24 hours a day, 7 days a week, can be replicated for greater speed, can work from any location, minimize risks as they are less prone to errors. The possibilities of RPA are practically endless since it can address any sequence of tasks. For example, it can open emails, log in applications, read databases, access files, perform calculations, fill out forms, etc. Therefore, the scope for technology is any department or sector that uses Office and IT applications. But not everything is bad for the worker. Now, employees can dedicate their time to generating added value for the company, focusing on problem solving, managing exceptions, developing strategy, creative improvements. RPA is becoming established as another technology to help companies achieve a successful digital transformation and remain competitive in the market.
So that is just a quick introduction on what robotic process automation is. So I'd like to play the next video. So the next video demonstrates RPA in action so that we can see the relevance of robotic process automation, big data analytics. So it's a bit longer than the first one, but can we just have a look?
Today, we'll look at how robotic process automation can increase employee productivity and remove time and cost from business processes. We'll use an account opening example to see how robotic process automation, or RPA, reduces manual processing time, eliminates copy and paste errors, and improves customer service. The process starts when a call center rep offers a new line of credit account to an existing customer. The rep uses IBM Business Process Manager, or BPM, to document the customer's request, including specific details about the property being used for collateral. All other customer information will be pulled from existing systems when a sales assistant creates the account. When the call center rep submits the request, BPM automatically launches an automated decision service in IBM Operational Decision Manager, or ODM, that determines the allowable amount of credit. Since the credit decision completes in real time, a task is immediately generated for a sales assistant to manually create the new account. It takes a sales assistant about 20 minutes to open this new account, but due to a 3 business day backlog, the account can't be opened until next week. It will therefore be several days before we send the customer documents to sign. The following week, a sales assistant opens the task and sees the information entered by the call center rep. She also sees the credit limit and a credit limit confirmation ID that was assigned by ODM. The sales assistant's task is to now use this information along with information from 2 other applications to open a new account in the line of credit account system. The assistant starts by logging in to the Customer Information Master System. She then copies the customer number from BPM into the master system in order to retrieve master customer details. She then logs into the line of credit account system in which she will open the new account. She returns to the customer master system and one by one copies and pastes all 9 values into the account opening system. She then goes to the BPM system and again one by one copies 10 values into 11 fields in the line of credit system, since one of the values must be pasted into 2 separate fields. She then logs into a government website to obtain the official tax value of the property being used as collateral. She copies the property information from the BPM system to the valuation website and retrieves the tax valuation and assessment date. She copies these 2 values into the line of credit account system and is finally ready to click Create Account. This causes the system to open a new account and generate an account number, which she pastes into BPM. That completes this human task and causes the BPM system to move to the next step in the process, which is to prepare the documents and send them to the customer for approval. The sales assistant is now ready to move on to her next task after taking a quick break to grab a cup of coffee. That manual task, which took 20 minutes to perform, required logging into and navigating 4 applications and copying and pasting 36 fields. Now let's replay the exact sequence of events using robotic process automation. RPA is able to record all the actions performed by the sales assistant and then play back the actions on command. This includes logging into applications, navigating to specific screens, controlling applications using the mouse or keyboard, and copying and pasting values between applications. Let's watch as IBM RPA completes this account opening task less than 45 seconds after the call center rep clicks the Submit button. Using RPA, we were ready to send documents to the customer 45 seconds after the call center rep finished speaking with them, which is a much more efficient and effective outcome than having to wait 3 business days for a sales assistant to spend 20 minutes performing this repetitive and error-prone task. The benefits of using RPA in this example are pretty clear. First, we were able to respond to the customer in 45 seconds versus 5 calendar days. Second, we eliminated the copy and paste errors that often occur in as many as 10% of manually copied customer records. And third, we can free up our people from this type of mundane and repetitive work so they can focus on the things that humans do best. Things like providing personal empathy to customers or using creativity to solve problems or find new business opportunities. IBM.
All right, so let me end it here. A disclaimer that I should have stated before I played this video is that I am not at all trying to sell IBM's products here.
I was wondering.
Right.
It's a good IBM one.
Yeah, though I have worked for IBM before, I'm not at all trying to promote their products. However, this is one of the great videos out there that just showcases how RPA works, right? So if you look at the different tools or the different applications that the clerk has to access to process a custom application to open an account. So it's multiple applications, multiple platforms. So if you can liken that to the various data sources when we're speaking about an analysis or a data analytics exercise, right? When you have to collect data from multiple sources. So you have people doing all these things at once. But if we can then start bringing RPA, we can ensure that the most of the time is focused on actually doing the analysis, right, instead of focusing on the data. And it gets worse when you are dealing with unstructured data, because then it must be sorted, it must be fixed, it must be cleaned, a lot of things must be done. Even though there are many analysis tools that say they can definitely process unstructured data, but that data must still be collected and correlated, and everything must be done to it. So if you look at bringing RPA in the space, you would add a lot of value and you'd save a lot of time. I want to mention that RPA has gotten so advanced that before, you would have to bring in a machine learning component to integrate with your RPA for you to be able to achieve greater results. But a lot of these tools these days are already built with machine learning, so they learn. The more they work, the more they learn. The more they work, the more they learn. And they also have capabilities of processing unstructured data. One interesting other factor about them is that you find a lot of data, for instance, from scanned documents, right? It is very difficult for a lot of platforms to read data or text from scanned documents. But a lot of these robotic process automation platforms come with that feature now. They can read scanned documents. We even have these tools that can also read handwriting, right? So that is how advanced they've become. So if you bring in robotic process automation and machine learning, you could streamline your data analysis exercises or activities to ensure that you realize a lot of value from that. As you can see, you could deal with the structured and unstructured data and you'd save a lot of time, right? So I just thought I should mention this. Not that these are the only available RPA platforms, but these are the guys that pioneered robotic process automation and have done it so well. Though there are so many other players today in the industry, if you look at the big names, your Microsofts have their own platform, your SAP have their own, Oracle, they have their own, but these are the big three that pioneered RPA, and they're still doing it as best as possible. And these are the three that I personally recommend. And again, disclaimer, I am not trying to promote any of their products, but I'm just saying from being in the industry for a while and having experimented with many of these different tools, Automation Anywhere, Blue Prism, and UiPath are the big three. Right. I would like to pause here for now, looking at the time, and welcome questions or suggestions or discussions.
So, Thulani?
Yes.
The one question I had, and I just like to confirm that I've been doing or seeing a lot of work we do with digital decisioning.
Yes.
And I did put on the chat there, and I sort of thought initially they were the same thing, but RPA tends to go a little bit wider in terms of really focusing on the process interaction and automation as well. So it's not just about when we've collected the data and we need to make a decision, that we can allow the machine to make a decision, which is sort of the high level discussion around digital decisioning. It certainly has all the rules and the decision trees that you've shared.
Yeah.
So it's not exactly the same scenario. I'm assuming that's the correct understanding, the difference between the two.
Yeah, so if you look at digital decisioning, right, you could actually integrate that with RPA.
Okay.
If you looked at the process on the video that we played, there's a part where the bot has to wait for a user interaction. So a user has to make the decision, right? So that is the space where you can bring in the digital decisioning, where all the decision trees are built in to just digitize the whole process in the platform. Yeah. So the two work hand in hand together. That's correct, Howard.
Thank you. And just a quick question: are there any open source tools in this area?
Yeah, there are. There's a lot of them. Let me just mention though that UiPath has two different offerings. They have the on-prem offering and they have the cloud offering. The cloud offering is free.
Okay.
Yeah. So, and the great thing about that is that there's even their certification and academies are free. If you go on the cloud platform, so you can look at that if you don't necessarily want open source, but you want free stuff. UiPath has that option, but there are a lot of other open source platforms available. Yeah.
And then there's another question from Connie. Her question is, could you use RPA to bring all the information together that you need for digital decision?
Yes, definitely. Definitely. Whatever you can do manually, especially if it's a sequence of tasks, you could do with RPA. For instance, if you collect all your data and you put it in an Excel spreadsheet that you then use as inputs on your digital decisioning, you can certainly apply RPA there and you can achieve that, definitely.
Okay.
Yeah.
But it's not as, I mean, would I be correct in saying it's not the same as if you get any input file, any structured input file that it could work out what the transformations are required to achieve a standardized output file?
Yeah, so RPA has a programming component of it, right? So it depends on how deep you want to go.
Right.
So if you want to go to the level of actually doing some work within the document itself, right? Building in transformations using code, you could do that. But if there are other tools that you could use for that, therefore you can just use RPA for the data collection and use that data as input. For instance, if you want to build in, you want to get in different data sources, multiple Word documents, for instance, and you want to traverse those different documents and put them together to create an Excel file as output from all the different inputs. You could then write that code within the RPA platform, the engine, to make those rules happen, right? So it really depends on how deep you want to go with it, but those capabilities are there.
Okay.
Yeah. Yeah.
Good. Any other questions, guys? Can you, if you want to ask a question, you put your hand up.
No, I know. I actually get this a lot, that I am a very good speaker. So things just become clear.
10 out of 10. I'm glad. Normally I go a bit quiet. I'm not sure what to say. Oh, we got Marcel Elf. He's got his hand up. Marcel, how are you doing?
Good, thank you, Howard. Yourself?
Yes, fantastic. Thank you.
Right. Just maybe a question I couldn't attend from the beginning, but how does RPA fit into the data science environment?
All right. I don't know if I should test if the audience were listening, because that was basically the discussion today. If anybody would like to respond to Marcel.
I will listen to the recording. Don't worry. Thanks.
I can. I mean, I can try. I wouldn't mind trying if no one else is keen.
No, no, it's fine. Marcel. So what we're discussing today is we are looking at this one specific use case. If you look at when you do data analytics, right, you need to collect data from multiple sources, right? Some of the data is unstructured, some of the data is structured, and the unstructured data must be fixed and must be sorted, right? And you must use that as input in your data analytics tools. So in this instance, we are looking at utilizing RPA for the data collection component, so that at the end, you just have one source that you can then use as inputs in your data analytics tool. So instead of a data scientist, a data analyst conducting exercises of collecting data from multiple sources, you can just bring an RPA to do all that work. And as a data analyst, you just focus on the analysis of the data.
Thanks a lot, Thulani.
All right, Musa.
The question from Esti, Thulani, if not, has Papaya influenced your work in RPA a lot?
No, not really.
So if we think of, that's a really interesting question, because if we think of all the things that people need to do, for example, building a registry of the processing activities, cataloging all the data assets, looking to see whether there's sensitive or PII or SPI information.
Yes.
I'm assuming that a lot of these things that are really manually intensive, RPA could certainly be applied to.
No, definitely hard. If you look at, I mean, exactly as you're just saying, right? We can apply RPA to make sure that we are compliant when it comes to data.
Yeah.
Yeah, in different aspects.
That should be quite nice. So, okay, then we got another question from hands up from Super Cisle. Sorry, I'm not sure. I was battling for the pronunciation. Apologies.
Hey, Thulani, you should have left Howard to actually
to battle. I was struggling.
Maybe we should RPA him. Hey?
I was going to ask my wife. Well,
yeah. Okay, then Thulani, I just wanted to find out, man. What's the difference between the RPA and the ETL tools? Because you can also set up the ETL tools to actually collect data and all those things. So I just wanted to find out the difference between the two things.
Yeah. So if you look at the ETL tools, right, their jobs or their job is just focused, right? But RPA, the scope is limitless. Though this use case is focused on data collection, but RPA goes beyond that. So you could do anything that a human do on a computer, right? So ETL is built for specific stuff, whereas RPA goes beyond. So the RPA, you can do as much as you can imagine with robotic process automation. So the applicability of it is very vast compared to just the ETL tools.
Okay, thank you.
Yeah.
And Cecilia, I also believe that because it's got the machine learning, the requirement that Thulani brought up in terms of the coding. So ETL is all about you've got strong engineers and that are continually coding and transforming the data. This becomes more of a process of machine learning and the ability to help us apply those transformations and reduce the coding.
No, definitely. Thanks, Howard.
Okay, thanks.
So always, I think that's for Marcel as well, this idea of when you're really making use of the machine learning and the different elements, then you should be seeing a reduction on the coding side as well. So if there are skilled requirements for coding, machine learning is going to help you in that area.
That's correct, yeah.
Any other questions, guys? Thulani, thank you very much. Mishima, would you like to say anything? Any comments from your side? Being in a telco?
I just want to say thank you, Thulani, and we hope to see you back here again.
Yeah. Yeah.
No, thank you so much, guys. Thank you for the invites. Truly appreciate it. Thank you.
Excellent. Guys, thanks everybody. Thanks. We'll make the recording available. We'll make the announcement on LinkedIn. And thank you everyone for attending. And have a fantastic evening.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye.
Cheers. Cheers.
Bye.
Cheers, bye.
Thanks, mate.